Hi, I'm Adam Malone, and I am the head of customer engineering for Hasura across APAC. And I'll be talking today about transcending microservice hell in search of Supergraph Nirvana. So anyone who's come to this talk expecting us to be discussing the music of Kurt Cobain and Nirvana, so sorry to disappoint you. This is all about Supergraphs. So quick introduction to myself. I'm Adam, based in Sydney, and I work with customers all across APAC. Now, customer engineering is something that a lot of organizations are starting to adopt when bringing in new technology. And the main reason that I work as a customer engineer is to help customers adopt new technology, in this case, adopting Supergraph technology, adopting Hasura, especially as they're looking at different architectural patterns. This is a lot of the work that I'll do with them. Now, I've been in open source for basically the entirety of my career, and you can find me over on GitHub there. I don't know who that guy is. That's what I use, I think, for catfishing over on LinkedIn. So a quick agenda for what we'll be covering today. We'll do a little bit of a trip through time and understand kind of how we got to where we got to today architecturally, a dive into what supergraphs are and why it's really, really important to care about composability, and then I'll run through a brief demonstration. Final thing I'm hoping that we cover, and the final thing that I'm hoping you take away, is that you get a little sense of malaise about how you're doing things so far and why you should use a supergraph. So a bit of a trip through time, and I think working with customers over the long haul, what I found is that kind of the right way to do things changes all the while. I don't know if anyone here remembers way back in the day when the kind of experiences that we created were generated by static pages from a server, spat out directly to clients. But that was definitely a thing that happened. Then, I don't know if there's anyone who's watching this who remembers edge side includes, but they were a thing as well for a while. Not anymore, at least they shouldn't be. But edge side includes were kind of the way that people said things should be done. Then we moved for about 6 months or a year into single page applications. I'm sure everyone's built a single page application whereby, we shove a whole bunch of JavaScript down towards the customer, down towards the client, and then that would work on their side to create some pages. And now the trend has moved more to React server components and more back-end for front-end systems, where we're doing a little bit of work on the back end, a little bit of work on the front end, but doing it in a bit more of a modern style. Now, the right way to do things often changes for a number of reasons. Back in the day when we started creating microservices, everything was meant to be API-led. It was, let's create interfaces for everything. AWS was doing it. Microservices is the new hotness. Let's create APIs. Then we moved into a data-led part of the time where we wanted to store a lot of data. We built data lakes, we built event streams, and we didn't really know why we wanted to do it. I think it was more of competition to see who had more petabytes, but everything became data-led. And I think the most recent trend, and this makes most sense to me, is taking a bit of the API-led, a bit of the data-led, and combining it together to be data product-led, where we're using data that we've got within our domains to provide insights to both internal teams and other customers that we've got by way of creating and constructing data products. Now, data products actually have value. People can use them. People are able to consume them. And we're, as data product providers, able to make commercial arrangements out of them. So if we have data, we can provide it, and people will pay us for it. So there's a lot of benefit to that as well. Now, the right way to create these architectures has changed in line with these patterns. If we remember the monolith, I have a soft spot for monoliths. I think for certain purposes, they're really good. And then we started creating microservices because we started creating different databases. I often use the analogy that, if Facebook was created today, it wouldn't use a large MySQL store for everything. There'd probably be a time series database. There'd be some NoSQL stores. I'm sure Cassandra would pop up somewhere. There'd be lots of different stores for the data that was stored inherently within the system. But because we created all these different databases, we had to build microservices that could access those databases. And typically the teams that operate those databases, operate those data stores, are the teams that build the microservices that allow users to consume information across them. Now, with one database and one microservice, it's quite simple. But as we're starting to create many, many domains and many, many different data sources, you start getting a really complex web of connections between those front-end applications and the back-end microservices. And this is only made more complex when we start introducing things like stream processing, because then we start having things like operational data stores that are looking at individual topics and providing, again, more data sources for us to connect to. So if you imagine yourself as a new developer coming into an organization or being moved onto a different project and having to start working out, okay, where do I need to connect to, and starting to connect all the dots and create all of these different connections between these different back-end microservices, it starts to be quite overwhelming. And I think this is the reason why it takes a long time to create data products, because we're connecting to lots of different places. We're having to do all of the orchestration and gluing together of data from many, many different data sources. There's no composability behind this. So one of the things that we've seen a lot as we start moving, again, progressively into this data products world is this decoupling of API layers. This decoupling of the backend API, and this backend API is kind of the secure place that is the keys to the kingdom, the keys to the data, and the front-end API that conversely needs to move really, really quickly in order to meet customer demand. So our product teams, they manage the front-end APIs. They want to move quickly. They want to do a little bit of logic, a little bit of orchestration, perhaps a little bit of customization of those APIs. And again, each team who owns the apps also owns that BFF. The backend layer, they're responsible a lot more for data modeling. They're responsible for security, alignment to authentication and authorization solutions. And those domain teams are responsible typically for the data source, the data that's within it, and the microservice that usually provides access to that data. Problem with this is, as we saw before, everything looks like a massive spider's web that we get caught in as a new developer. So building and operating all of these microservices is really quite a challenge. And because it's a challenge to create new microservices, we want to make sure we're getting safe, secure, performant microservices. The product teams often have to wait for microservices to be created, so they can't move at the velocity that they want to move. So in the name, in kind of the words of the inimitable Bill Lumbergh from Office Space, often our product teams are sitting there at the front end saying, hey, we really need these microservices, get them created for us. This is where we're starting to see what some people call serverless monoliths, some people call backends for databases, and others call supergraphs, where there's this composable API layer that sits between the experience layer and the data layer. And it provides that conduit through which API calls can be made from the front end to comprise multiple pieces of data from the back end. And oftentimes what people think is that because it's a supergraph, it's got graph in the name, we have to use GraphQL for it. We have to start to build GraphQL services on top of our microservices and another GraphQL service that kind of stitches everything together. So there's one thing that I want you to take away out of the two things from this presentation. I want you to understand that a supergraph itself is both an architecture and an operating model. And it's used to take data from multiple different back-end sources and comprise one single graph of that data. What we want to do is we want to abstract where the data exists, the data domains, the teams, all that organization, and allow governance to bubble up from underneath into this unified supergraph layer. Now, where that word supergraph comes from, it's actually not a new term. Supergraph was invented as a term by the creators of GraphQL. That's Nick Schrock and Lee Byron. And we can see the RFC for the supergraph here back in 2012. The idea was that they'd create this supergraph, and the supergraph comprised, based on graph theory, of multiple subgraphs, usually based on things like GraphQL. But what we actually only got was the GraphQL specification for it. So a lot of organizations now are building their own supergraph. They're realizing that, hey, we need this layer that exists between all of our backend domains, our backend data sources, and our front ends in order for us to consume data really easily. And GraphQL is often a choice to use for that, but it doesn't have to be. So what should a supergraph do if we've got this intermediate layer that exists between Experience API and Data API? What should a supergraph do? Firstly, it should be unified and semantic. Regardless of the number of different data sources, we want that to unify, bring together all of the information from multiple data sources and provide a really simple way for front-end APIs and front-end clients to be able to talk to those backend domains. It needs to be composable. We need to be able to make one API call to the Supergraph and have that information brought together from multiple different sources in one go. We don't want to have to deal with that N+1 problem. We don't want to have to deal with multiple different API calls. We want to make one API call and have all of that information retrieved for us in one go. Governance needs to be included out of the box. Obviously, we want governance at the Supergraph layer, but that governance is bubbled up from those underneath layers as well. Different domains have different authorization rules. There's different privacy. There's different PII information or PII that exists within those domains. We want to make sure that any of the rules from any of those domains, any of the governance across any of the data gets bubbled up into that overarching layer. We also don't want it to have to include a whole team that manages that Supergraph layer. Ultimately, it should be a composition or a sum of all of its parts. So the Supergraph itself should take metadata, should take information, should take declarative metadata from anything underneath it and create one layer that exists to be consumed. And finally, it should manage all of our query planning and distributed execution. We shouldn't have to have any SQL being written. SQL should be generated automatically, it should be compiled automatically, and it should be done in an optimized fashion. So the Supergraph should manage that. It should have an understanding of the query plan. It should have an understanding of what would make a good and effective execution, and it should run it in a distributed fashion across any number of backend sources. So the second of the two things that I want you to take away is that composability is #1 importance. If you don't have the ability to take a query, take a request, and have that composed across multiple different backend sources, really all you've done is you've built an API gateway that takes a request and sends it over there or sends it over there. What Supergraphs need to do, highly important, is take one request, compile multiple pieces of data from multiple different backend systems and send it to the front end automatically. So quick intro as how Hasura has built our Supergraph. Done a couple of different things to ensure that we align with Supergraph principles. Within Hasura, what we've done is we've used the data loader pattern for composability. What we do is we eliminate that N+1 problem by constructing cross-database joins really, really efficiently. And I've got an example around how we do that later on. We also take a connector-first approach. So rather than building a microservice on top of our database, and then building a GraphQL resolver on top of that, and then absorbing that within the microservice, we create data connectors that integrate directly with data sources. So it doesn't matter if it's Postgres or a Postgres derivative like RDS or Aurora or MySQL or Snowflake or BigQuery or even REST and GraphQL microservices. We connect directly to those, which means that we can use those native query languages to talk to them. It becomes a lot more efficient. It also means that authorization is passed down for free using techniques like predicate pushdown. We can push all of our predicates, all of those rules, all those authorization parameters directly into an SQL query, compile it automatically, and have all of the governance again followed at the database layer. So authorization, in the words of the janitor at Arthur, he does it for free. Authorization is included within Hasura for free. We can take any query, and what you'll see here is I've color-coded each of these based on the database that it's in. I've got a Postgres data source for my user information. I've got a Mongo store for Know Your Customer, and I've got a separate Postgres source for loyalty points. And I can overlay any number of different auth parameters. It could be role-based with, say, tokens. It could be client-based, based on time of day, IP address, geolocation, or it could even be something like attribute-based, information that exists in a database already, such as this PEP, which is politically exposed person status. Any of this information and bake it directly into the query. The way it does that is via the Open Data Domain specification. And here's an example of that for the query that we're about to write. This query shows us that for anything within the Know Your Customer data store, this user can only get access to it if their PEP status is not none. So we're using information in the database to define the information that that user who accesses it should be able to create. It gets rid of this idea of ACLs. We don't need ACLs anymore. We can use attributes directly from within the database. The second one that we've got there is that people should only be able to access their own data. So for that users table, the user ID should map to the token value that we're passing in. So we can take any number of these different pieces of metadata and use them to construct SQL queries that run against the data source. And a lot of banks are starting to use this declarative metadata as a way to take policies that they've got in some kind of centralized policy system like Open Policy Agent and automatically compile declarative metadata that then gets loaded in at the domain level and absorbed into Hasura. So again, we have that seamless transition of rules. So taking a look at the composability, the way that this will operate is we'll take one query, we'll hit our first Postgres database, and that might look something like this. Now remember that 3 there, that user ID equals 3 is coming from the token. It's coming from their already authenticated token. We then take the result of that and fire it off against the second data source. So we're using information from the first database, using information from the first response, and sending it to the second data source. That's our data loader pattern being built in. And then we're taking our second query, our second response, and we're building that in with those attributes from the table into our Mongo source. So let's have a little look at how that works in real life. Now, this is a blank Hasura instance that I've got ready to take our queries. I've got nothing in here at the moment. And what I'm going to do is I'm going to add all of those different databases to Hasura. I'm going to add in an accounts database. And this is our first Postgres database. And you can see that as soon as I add this database, Hasura is tracking this information. And it's going to be, and we're going to be able to create these semantic relationships between different data objects within Hasura. So you can see it knows that my accounts are related to credit cards. It knows users have accounts. It knows accounts have users. And by tracking all of that information, that allows me then to create that API instantly on top of all of the data that exists within the API. So taking a look at the API, now I've got information in here. I can start to query that information. I can have a look at all the users and the names and the IDs in my users data store really, really quickly. Now, where authorization kicks in is when I start to pass tokens to Hasura. The token that you'll see here is JSON Web Token, and you'll see that I've got a couple of different authorization parameters. These have been passed to me by the token, and I can say, hey, my user ID here is number 3. So when we start thinking about creating that authorization rule, if I add the token in and run that again, I only get access to information that I should have access to. From a front-end perspective, we've asked for the ID, the name, and the tax file number of that user. But what Hasura's done in terms of creating the query that runs against the data source is it's taken this query and it's added in a where clause. It said where this user is user number 3. And that's really, really important. We want to make sure that we've only got access to information from that user. So what I'm then going to do is I'm then going to start adding in a couple of different databases. Let's go back here. Let me add in my loyalty data store. There's my loyalty data store, and I'll connect that up. And I'll also go ahead and connect up my Mongo data store as well. So I've got Mongo data store, there's my connection information, connect that up. And now what I can do is I can start constructing a fully composable API across all of those different databases. Those 3 databases, I can take the query that's run, and I'll copy that in from over here. This is the query that we get. We're looking for users, know your customer, and points balance. Hop back over to my API. And if we take a look at the API, what you'll be able to see, we've got that authorization parameter built in. When we run that, we only get information from this one user. We get information from Rory. This is his tax file number, his name. We get information from Mongo. That's our know your customer information, and his points balance as well. So we get all of that information in one shot simply by connecting them up and constructing that composable API with Hasura. So that's the end of the presentation. I know we've got a couple of minutes here, so please feel free to scan this. This is my social information here. And any questions, please feel free to shoot them through. I'd be more than happy to answer those after this talk. Thank you ever so much.